Alright, so I got about 14 questions from emails from you guys, so I'm going to go through and work through each of those questions to hopefully help you understand them a little better. So the first one was 36, asks for the volume of a gift box, gives you an equation, and tells you that the domain is between 0 and 3. Asks for the height of the box. So for this problem, you can use your calculator. So ultimately what we're going to look for is for the maximum volume. Volume is your y value, so looking at your graph, you're going to look for this point here. And whatever x value is there, since h is your height, whatever h value, which will be represented by x in your graph, is going to be your maximum height, or is your height for the maximum volume. So the first things first, put the function in to your calculator. Alright, and it says the domain is 0 to 3, so I'm going to go to my window, and I'm going to, for my x-min, I'm going to put 0, and my x-max, I'm going to put 3. That'll help me get a better picture of the graph. And then my min 0, because we can't have a height less than 0, or I'm sorry, our volume can't be less than 0. And for max, I just put in 50. Just picked a number. Could have put 20 and then see how it works, but 50 works out nice. So then all you're doing is second trace, go to the maximum value, left bound, so we're going to go slightly to the left of my maximum. I'm going to go slightly to the right of my maximum, and then I'm going to guess. And it gives me 1.21 with a maximum volume of 32.8. Now we have to make sure we read the directions here, three places after the decimal point. So my maximum height is going to end up being 1.214 units. It doesn't give us anything, so we would just say units. Really, you could probably leave that blank. So that's 36. Now we jump to 47. It says to fill the blank with the number that will complete the trinomial square. So all we're doing here is completing the square and entering that last value. If you remember, all we're doing here is adding b over 2 squared to the end of the equation. So if we were solving, we'd add it to both sides. Here we're just completing the square. So b, remember, this is in the form ax squared plus bx plus c. So b is negative 6, so I'm going to get x squared minus 6x plus negative 6 over 2 squared. X squared minus 6x plus, that's going to be negative 3 squared. X squared minus 6x plus 9. So that would be your final answer for this problem. And remember, this would simplify to simply just x minus b, or x plus b over 2 squared. So this would end up being x minus 3 squared if we wanted to simplify it further. That's what's so great about completing the square. 48, you would do the same way. For 52, it says an arrow is shot from a height of 32 feet with an initial velocity of 56 feet per second. The function for height in feet of the arrow at time t in seconds is given by the function negative 16t squared plus 56t plus 32. Again, notice we don't have anything saying we can't use a calculator. Alright, so question A, how many seconds will the arrow hit the ground? How many feet high will the arrow be at 1.5 seconds? And what is the maximum height the arrow will reach? So we know it's going to hit the ground at our 0, so we'll look for a 0. And we could do that using the equation and factoring, but again, if you're crunched for time, it might just be faster to use the calculator. What will the height be at 1.5 seconds? We're just going to plug in 1.5 for t and find our height. And lastly, what is the maximum height that the arrow will reach? Notice this is a quadratic function, so the maximum height will be our vertex, and we just have to find the y value of that vertex. So we can go ahead with our calculators, plug in this equation. Negative 16 x squared plus 56x plus 32. And I'm just going to go to zoom fit for this, so zoom 0, and see if it gives me anything pretty. and it looks like it's going to. So we can't quite see where it hits the ground, so what I'm going to do is go to my window, and I'm going to make my X max maybe 6, and see if that helps us out at all. And it does. Now let's look at the window and make sure we can see the Y min. We probably want to be like -10, just so I can see that x-axis and clearly see where it hits 0. So here we have my graph. So how many seconds will the arrow hit the ground? So I just go to second trace. 0 is number 2. Left bound, so I go as close to the left of the arrow as I can. I'm sorry, as close to the left of the 0 as I can. Hit enter. Go as close to the right. Guess, enter. And I get at 4 seconds. Remember, when you see this -2e to the -11, that really just means 0. So the answer to this would be 4 seconds. How many feet high will the arrow be at 1.5 seconds? So you could type this into your calculator, just plug in 1.5 in for t, or you could just, at your graph, just type in 1.5. Oh, I'm sorry. Hit the trace button and type in 1.5. Hit enter, and it'll give you your y value. And you see that at 1.5 seconds, it's at 80 feet. Again, you could have done -16 times 1.5 t squared plus 56 times 1.5 plus 32, and you'd get the same answer. For the maximum height, what we could do is take our 2 zeros, find the midpoint, and then that'll give us the x-coordinate of our vertex and plug that into our equation and get the y-coordinate. But since, again, we're lucky enough to have our calculator here, I can go to second trace, and go to my maximum, and then just do left bound. Dun, 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 dun. And then right bound. Guess. And we see that the maximum height is 81 feet. So that would be the maximum height the arrow will reach. And that's it for 52. Going to 53, if f of x equals -x squared, on what interval of x values is f of x increasing? So we can look at the graph of -x squared. We should have a pretty good idea of what that looks like. If not, you can just plot some points. So you can clearly see, looking from left to right, it's increasing here. And it's increasing, going up, 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 until it hits 0. So the answer to this would be we always go left to right, so -infinity to 0 is when it is increasing, or you could say -infinity is less than x is less than 0, or really you could just say x is less than 0. When x is less than 0, it's increasing. A polynomial function has a general form p of x equals a big mess, where n is a positive integer. Describe the left and right n behaviors for the following values. So this problem looks pretty complicated, but it's really not. All this is saying is that a sub n is just my leading coefficient. Alright, and x to the n is just my power. So remember, we have the big chart that tells us all of these things, and we'll go through each one. So if a sub n is positive, so that means I have a positive leading coefficient, and n is even, that's essentially like y equals x squared. So that looks just a rough sketch like that. So I know that as x goes to infinity, whoops, that's a rough infinity sign, f of x goes to, so as I go infinitely to the right, this goes up to positive infinity, and as x goes to negative infinity, f of x still goes to infinity. Alright? If a is positive, n is odd, so you could either, I like to look at the graph of y equals x, because that's nice and simple. So we have something like this. So as x goes to infinity, we can see f of x also goes to infinity. And as x goes to negative infinity, f of x also goes to negative infinity. So we can continue with that. For a is negative and n is even, I can look at the graph of negative x squared. So both will go to negative infinity. And if my leading coefficient is negative and it's odd, I can just look at the graph of y equals negative x, which looks like this. So that would, as x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to infinity. Whew. So all you're looking at there is your, as x goes infinitely to the right, and as x goes infinitely to the left, what is happening to your y values. '57, we want to write a polynomial function in factored form for the graphs shown below. Remember, factored form is just giving you your zeros. So it'd be like x minus h, x minus p, x minus q. That's factored form. That's all it is. So here I have zeros at negative 2, 3, and 6. So my equation in factored form would be x plus 2 because it's minus negative 2, x minus 3, and x minus 6. And that's all you have to do for that. That would be your final answer. Jump to 61, 62. It wants us to find all zeros and show how we determine them. So for this, we should notice this here is a difference of cubes. So remember that equation is a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. So 125, the cube root of that, is going to be 5x. Cube root of 8 is 2, so I have 5x minus 2. And then I'm left with 25x squared plus 10x plus 4. Right? And a lot of people from this step right here like to think, okay, well, the a times b is negative 10x, but that's already accounted for. This sign here is always opposite from this sign. So it's still plus 10x, even though ab is negative 10x. So from here I can see, all right, 5x minus 2, this remember equals 0 now. So 5x minus 2 equals 0. You're going to get x equals 2/5, but this over here does not look like it factors nicely. So what I'm going to have to do is the quadratic formula. So I get x equals negative b plus or minus radical b squared minus 4ac all over 2a. So x equals negative 10 plus or minus the square root of 100, which is b squared minus 4, a, which is 25, c, which is 4, all over 2a, which is going to be 50. Alright, so I'm just going to simplify this. So negative 10 plus or minus the square root of 100 minus 400 is negative 300. It's nice and pretty. Over 50. Now when we have a negative under a square root, first thing we want to do is take out that I. So negative 10 plus or minus I root 300 over 50. And then 300 we can take out we can change to 100 times 3. Square root of 100 is 10. So I get x equals negative 10 plus or minus 10I root 3 over 50. I can cut a 0 from each of these. So my final answer would then be x equals 2/5, negative 1/5, plus or minus I root 3 over 5. So there we have 3 zeros, and we found the first just by simply doing difference of cubes in solving, and then we found the second by doing quadratic formula. Alright, moving on to 70. A fourth degree polynomial with real coefficients could have how many imaginary roots? So potentially, a fourth degree polynomial with real coefficients could have 4 imaginary roots. Because we know it has 4 zeros, right? But those 4 zeros, if we have 2 sets of imaginary numbers, they could all be imaginary. So we could either have 4 zeros if the 2 sets, we could have 0 imaginary, or we could have 2 imaginary and 2 real. The big thing to take away from this question is that the imaginary roots come in pairs, because we always have that plus or minus. So like plus or minus 3i, and that comes from a quadratic formula. So that's the big thing from here. The imaginary roots come in pairs. You can never have just one imaginary root. If you have one, that means you have 2. You have a second. Alright, 71. We want to know how many zeros does this function have. So this problem is differentiating between zeros and real zeros. For zeros, it's just whatever the power of the function is, that's how many zeros it has. So this function, how many zeros does this function have? 4. For how many real zeros does this function have, we would actually have to solve for our zeros. So looking at this, it looks like we can use our calculator for part B. So I'll pull that up. I'm going to enter this function in to y equals x to the 4th minus x, minus x, minus 4, delete everything else. I'm just going to go to zoom 6 here. That's my standard. And it looks like I have 1, 2 zeros. So all I'm looking at is where it crosses the x-axis. That's where my zeros are. And we can see that those are here and here. I don't really need to know what they are, but it just asks how many, so the answer would be 2. 72. Let f of x equal x to the 5th minus 3x squared minus 4. Again, I cannot use my calculator, but I don't need to, because for the number of zeros, all I'm looking at is my biggest power. So zeros, I have 5 potential zeros. How many real zeros do I have? That means when does it cross the x-axis. So again, I can use my calculator. Type in this function, x to the 5th minus 3x squared minus 4. Again, take a look at this graph, and I see 1, 0. So that's all we have. So the answer to that would be B, 1, 0. 73. Solve the inequality x to the 4th minus 5x cubed minus 25x squared plus 65x plus 84 is greater than 0. So from here, we can clearly see I can't factor this. I don't know how to factor this, so I can't get my zeros. So that's ultimately what I want to know, when this is greater than 0. So what I can do is get a line, and then I'm going to graph this in the calculator and use that to find my zeros. So I have x to the 4th here minus 5x cubed minus 25x squared. And make sure you're very careful when inputting these values. It's very easy to make a mistake. Alright, and I'm going to graph this, and I may not be able to see it on this standard Alright, so it looks like I have 4 zeros. So these actually look like they're nice and pretty. So I can go to second table, and this will show me where my zeros are. So I have one at -4. I'll bring this over here so I can see. So I have -4, -1, 3, and 7. Alright, and normally from here I would pick test points, but I really don't need to because I have these values here. So from -4, before -4 it's above 0. So I know that from here and over it's going to be above 0. From -4 to -1 it's below 0. And then it looks like from -1 to 3 it's above 0 again. I'm just looking at the y value to see if it's greater than 0 or not. And then from 3 to 7, we drop below 0, and just to make sure, from 7 on, we are above 0 again. So that would be what your line looks like, and your final answer would be x is less than or equal to -4, -1 is less than or equal to x is less than or equal to 3, and x is greater than or equal to 7. So again, that's really just using your calculator and then checking out those values at between your different zeros. Here wants us to do the same thing, but they give us a graph. So this wants to know when it's less than 0. So my zeros are -3, 1, and 6. So I can see pretty clearly when x is less than -3, it is less than 0. So I'd say, okay, when x is less than -3, then it's above 0 until I get to 1. And then from 1 to 5, it's below 0. I'm sorry, this should not be equal to because it just says less than. And then from 5 on, it's above 0. So those would be my only two intervals where it is less than 0. 75 gives us a function, and it gives us our zeros. My zeros are x equals -6, -1, and 8. It wants us to write the polynomial in factored form. So factored form, they give us our zeros, so it would just be x plus 6, x plus 1, x minus 8. So that would be the function in factored form. And then those are my zeros. So that's what I'm going to put on my number line. So I have -6, -1, and 8. So here I am going to want to pick some test points because I cannot use my calculator, so I'll pick -7, -2, 0, and 9. And remember, here I can simply plug these values in here and look at the signs. Alright? And here it's asking for when it's less than or equal to 0. So if the sign ends up being negative, this statement will be true. If it ends up being positive, the statement will be false. So for example, I'll show you. X equals -7. -7 plus 6 is negative. -7 plus 1 is negative. And -7 minus 8 is negative. So all three are negative. That gives us a negative, which tells me that this is, in fact, less than 0. I'm sorry, that should go from -6. Alright, now I'm going to try my next test point. -2. -2 plus 6 is positive. -2 plus 1 is negative. And -1 minus 8 is negative. So negative is a positive, This is positive, so that part is not less than 0 because a positive number cannot be less than 0. Next I'll try 0. 0 plus 6 is positive. 0 plus 1 is positive. 0 minus 8 is negative. That's going to result in a negative, which is less than 0. So I know that from 1 to 8, -1 to 8, it is less than 0. And just based on the pattern, it doesn't look like this is going to work, but we can do it anyway. just to be certain. X equals 9, so I get a positive, positive, negative. So, oh, I'm sorry, positive, positive, positive. So it's positive, and that does not work. So your final answer, switched back to blue, would be x is less than or equal to negative 6, and negative 1 is less than or equal to x is less than or equal to 8. So those would be those intervals on which that function, that polynomial, is less than 0. And that brings us to our last problem. Sam throws a ball from the top of a building. Write a polynomial function that best fits the data. How high is the ball after 4 seconds? When does the ball hit the ground? So this is just like the problem from the last quiz we did, where we're finding the common difference. Okay, the only difference is that the chart is flipped. So if we were to take this, rotate it on its side, we get something that looks like this: 1, 2, 0, 1. Whoops, forgot a number. 1, 2, 3. And I'd get 400, 434, 436, and 406. So just looking at those numbers makes me want to think it's a quadratic. I don't know for sure. So I'm going to go through and check. So I get 34, 2, and negative 34. Those are my differences. Those are not the same, so I'm going to go again. 2 minus 34 is negative 32. Negative 34, I'm sorry, 2 minus 34, I'm sorry, I'm going crazy here. 406 minus 436 is negative 30. So negative 30 minus 2 is negative 32. So we see my second power, my second common difference, so that means it's quadratic. So now I can go to my calculator, plug this in. I'm going to go to Stat, Edit, enter my x values in L1. Be very careful again entering these, and enter these in: 400, 434, 436, 406. And then I know it's a quadratic now, so I'm going to go to Stat, Calc, and select Quadratic Regression. Hit Enter. Whoops, I don't know why that 1's there, but let's see, it might not work. Yeah, that 1 should not be there. So Stat, Calc, Quad Reg, and here we get my function. So that would be y equals negative 16x squared plus 50x plus 400. So I entered that first function. Then it wants to know how high is the ball after 4 seconds. So I'm just plugging that in for x. I'm going to go ahead and just put it in my calculator, so it's nice and simple, and I can find it easily. Negative 16x squared plus 50x plus 400. I'm going to go to Zoom Fit, Zoom 0. Get something that looks like this. Alright, and that gives me everything I need. So how high is the ball after 4 seconds? I'm going to hit Trace, x equals 4, Enter. So I get 344 for that. 344 feet. And then when does the ball hit the ground? For that, I'm just going to do second trace 0, number 2, and go a little bit left of my 0. And a little bit right of my 0. And make a guess. Have the calculator make a guess. And it gives me 6.8 seconds. So 6.8 seconds, it hits the ground. Alright, so that is all the questions I got. Hopefully this little video was helpful with your studying. It's been a blast teaching you guys this semester. Hopefully I get a lot of you next time. Good luck on the final exam, and have a great weekend.